Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Jalan Hakim Hazrilai. So today, our group will explain about DC power supply based on rectifier and chopper, which is buck converter. So my part, I will explain about introduction. First of all, the agenda. Okay. In this task, we are given to design a DC power supply based on rectifier and chopper by using multi-sim and following the specification that have been given by our group. So first of all, for rectifier, we have to set it in AC input voltage VRMS to 110 and input voltage frequency is 60, and for chopper the switching frequency is in hertz is 40, and the range of output voltage in volt is 12 to 24.
Assalamualaikum. I am Nur Natasha binti Kamarudin from 3BEY 1/1. So I will present about the methodology. The methodology is about the calculation of our assignment. So first of all, we need to find the VD, which is the formula is set 2 times 2 V in. The V in given is 110. So the VD we get 155.56 volt. So next, we need to find the Dmin and Dmax. So we use the formula is V out equals to dVd. So the V out for min is 12. Then we put the Vd, which is 155.56. So the Dmin is 0.08. For the Dmax, the V out max is 24, so the Dmax is 0.15. Next, we need to find the inductor, which is the formula is 1 minus D times to RL over 2F. So the RL given is 100 ohm and the frequency given is 40K. So the inductor mean is 1 minus 0.08 times 100 over 2 times 40K, which is we get 1.15 millihenry. So the inductor maximum is 1 minus 0.15 times 100 over 2 times 40K, which is 1.06 millihenry. So next, we need to find the C min and C max. The formula we use is delta V out over V out equals to 1 minus D over 8 LCF2. So the L we get from the above. Then the frequency is 40K also. So the delta V out is 0.1. So we put all the values, so we get the C min is 7.5 microfarad. Then the C max is we get 15 microfarad. So next we need to find the RL. RL, which is the formula is set 2 times V in over I min from the simulation. So the I min from the simulation we get is 10.2 milliampere. So the RL we get 15.25 kilo ohm. So we need to find the R, the small r, which is the formula is 1 over 2 FRL. So we put all the value and we get the R is 0.546 micro. Then lastly, we need to find the C rectifier, which is the formula is 1 over 2 FRL R. So we put all the value of F, RL and R. Then we get the C rectifier is 1 farad. So that's all from me, Nur Natasha binti Kamarudin. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Ahmad Firdaus bin Muhammad Shah from 3BEY S11 with the numeric of P0820101141. Today I would like to explain about our simulation, which is this is our simulation. Our voltage supply is from AC and then our output is to become a DC voltage, which is we use rectifier from the circuit. We use rectifier AC to DC, and then from the circuit we are able to see the 1 farad capacitor, which is to stabilize the voltage supply, and then goes to the clock voltage, which is become a sinusoidal uh, wavelength, which is like a switching. So our our voltage supply becomes 150 volt uh, from the DC AC to DC rectifier. So after become DC voltage, we are using buck converter, which is DC to DC step down. So we are already calculate all the values of the capacitor and inductor. So for this simulation is maximum value, which is our maximum value should be to 24 around 24 volt. And then so after um, the simulation, we are able to get from 154 volt voltage, 154 volt to the and step down until 22.7 volt, which is in the value, in the range value. So this is our simulation. So our VPP is 155 from AC to DC, and then goes to voltage output, which is 22.7 volt. And that's all. That's all from me. Thank you.
Okay, I am Afiq. So we continue with simulation result, which component capacity fire. For the calculation is 1 farad and simulation 1 farad. For the minimum duty ratio, which calculation 0.08 and simulation 0.8. The maximum duty ratio 0.15 and simulation is 0.5. For the data chopper, which is 1.50 millihenry, and for the simulation we get 1.1534 millihenry. For the capacitor chopper, which is 7.5 microfarad, and simulation 7.543 microfarad. For voltage for the chopper, which is in simulation, we get 110 volt, and voltage for chopper we get 22.4 volt. I continue for discussion. A DC to DC converter known as a buck converter transforms the voltage into a lower voltage. Another name for it is a step down converter. A power transistor is turned on and off repeatedly by the converter, producing a sequence of voltage pulses that are smoothed down by a filter to provide a lower output voltage. A buck converter is influenced by the ratio of input to output voltage as well as by the converter switching frequency. The switching frequency is between a few hundred kilohertz and few megahertz. Numerous applications including as a power supply, battery charge, and voltage regulator are possible for the converter. Thank you.
Okay, I will tell you the conclusion of this assignment. At the end of this assignment, we learn about how to simulate DC power supply based on rectifier and chopper. Basically, we combine the two circuit, which is rectifier and chopper. Then we use the buck converter to step down the value input voltage value. So our group have given the specific value in appendix A, which is 110 volt for the input, and we simulate the circuit that we simulate in multi-sim, and we get the output value output voltage value about 22.4 voltage. So we can confirm that our simulation is succeeded, and finally we record all the theoretical and simulation in appendix D, which is we submit in the lab report.